Solve by completing the square. The first thing that I noticed for this example is that the leading coefficient is not 1, so I'm going to have to divide the entire equation by that value that's in front of x squared. And here we get a 4, so we're going to divide everything by 4. In doing so, now the 4's are going to cancel out, leaving me with x squared with a coefficient of 1, which is what I want if I want to complete the square. 20 divided by 4, that's going to give me 5x. Negative 12 divided by 4, that's going to give me a negative 3. And then 0 divided by 4 is just going to be 0. Here I have a constant, and to complete the square, I need to use the x squared term and the x term. So I'm going to move this negative 3 to the other side by adding 3 to both sides of the equation. And here let me create the fence just to make that more clear. The 3's are going to cancel out on the left hand side, so I'm going to be left with x squared plus 5x, and I'm going to leave some room for the quantity that I'm going to use to complete the square. On the right hand side, 0 plus 3 gives me a 3, and I need to add the same value, since whatever I do to one side of the equation, I have to do it to the other. To complete the square, I'm going to grab the coefficient of x. Here that's going to be 5. Divide it evenly by 2, and then raise that to the second power. On the right hand side, I gotta add that same quantity, 5 over 2 raised to the second power. On the left, now that I have the perfect square trinomial, I can factor that as a binomial squared by grabbing x and adding it to the value that's inside of these parentheses. So we get x plus 5 over 2, and then we raise that to the second power. On the right hand side, we have a 3 plus. Now notice that the 2 is not going to divide 5, so we're going to keep it as a fraction. Let's begin by exponentiating the numerator. So 5 raised to the second power is going to give me 25. That's 5 times 5. And then the denominator, 2 raised to the second power, that's 2 times 2. We're going to get a 4. To continue, we're going to have to simplify and combine these two values on the right. The 3, let's convert it into a fraction by dividing it by 1. And now we're going to add these two values by getting the common denominator. And I can obtain that by multiplying the given denominators, 1 and 4. 1 times 4, that's going to give me 4. And now I'm going to cross multiply here. 3 times 4 gives me 12. The original operation is plus, so we get plus the other two values multiplied with each other. 25 times 1 is 25. So here, 25 plus 12 is 37. So we get 37 over 4. So my new equation is x plus 5 over 2 quantity squared equal to 37 over 4. To get rid of this second power, we're now going to have to take the square root of both sides. And on the left hand side, the square and the square root cancel out, leaving us with x plus 5 over 2 equal to plus or minus. Now 37 doesn't have a perfect square, so I'm going to leave it as the square root of 37. But 4 does have a perfect square. The square root of 4 is going to give me a 2. Now to completely isolate x, we got to get rid of this 5 over 2. So let's subtract 5 over 2 from both sides. On the left, we succeed and have x by itself. On the right, I'm going to record this expression by beginning with the negative 5 over 2. So I get negative 5 over 2 plus or minus root 37 over 2. To clean this up, I notice that we have a common denominator. So let's combine these two together and form negative 5 plus or minus root 37 all over 2. And that would be your exact solution.